Welcome to C2.2.7, where we're going to look at polymer molecules. So we've had 2 lessons involving covalent bonding. So we had simple covalent molecules. Last lesson we had giant covalent molecules, and now we're going to look at polymer molecules. So before we start, pause the video and see if you can draw the simple covalent molecule C2H4 as both a dot and cross diagram and as displayed formula. Okay, so here we have a carbon atom. So carbon atoms are in group 4, so they've got 4 electrons in the outer shell. So I know I've got 2 carbons which look like that, and then I've got 4 hydrogens. So each hydrogen has 1 electron in the outer shell. So each hydrogen needs to gain 1 electron and each carbon needs to gain 2. So I can draw this out at the bottom. So if I because each hydrogen, I've not got enough hydrogens to go on each of those, so I'm going to put 2 hydrogens on each carbon to start with. So if I do that, so there's 1 carbon. Now I know I'm going to have to overlap, because I've not got enough hydrogens, I'm going to have to overlap the other carbon there. So that is 1 from the left-hand one from there, and then we've got 1, 2 there, because I'm going to overlap another one of these. Right, so if we look at that, the hydrogen's now happy because it's got 2 electrons in the outer shell, but each carbon has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, each carbon originally had 1, 2, sorry, they should be dots, shouldn't they? So each carbon has got 1, 2, 3 of its original electrons. It's got 1 more electron, which would make 7. But I can't just put it here because it's only got 7 electrons, so I'm going to move that one into the shared area there, and I'm going to move the one that would be there into the shared area there. And now, I apologise for the quality of my diagram, but hopefully we can see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully you managed to draw a little bit more clearly than me. Right, learning objectives. So you need to be able to describe the structure and bonding in polymers. So keywords we need to know. So I'll let you copy these down into your notes. So monomer is just a small molecule that joins together to make polymers. So polymers are big long chains molecules, but they're made from monomers, which are small molecules. And those monomers form the basis of the repeating unit. So each polymer has a repeating unit which is repeated many times, but we'll look at that in more detail on the next few slides. So before we start, think about what the word mono and poly, so the prefix, what does the prefix mono mean? So monorail is a train that's only got 1 rail. Monochrome means in 1 colour. A monologue is like me now, it's only 1 person talking. In chemistry, you've met monoxide. So carbon monoxide only has 1 oxygen as opposed to carbon dioxide, which has 2. And now we've met monomer. Okay, and then polyhedron in maths means a many-sided 3D shape. A polygon is a 2D shape, it's got many sides. Polyjuice, if you're a Harry Potter fan, you'll know that it means you can take many different forms, and polymer is what we're talking about now. So monomer and polymer, so mono means 1 and poly means many. So your monomer is the one thing that the polymer is made of, and then the polymer is lots of these monomers joined together to make a big long chain. So to summarise what we've already done, so we've looked at ionic compounds. So ionic bonding is where you've got a metal and a non-metal. So electrons are transferred between the metal, which wants to lose, and the non-metal, which wants to gain. Metallic bonding we haven't done yet, that's going to be next lesson. But that's just between metal atoms. And then covalent compounds, so covalent bonding is between 2 non-metals where the electrons are shared. So we've already looked at simple molecules, and giant structures, we're now going to look at polymer molecules. So what is a polymer? So a polymer is a big long chain. So they're very long chains of atoms which are joined together, and they're made up of smaller chemicals which are called monomers. So if you want to make a polymer, you get a monomer and then you do a reaction with it which turns it into a polymer. So we're turning monomers into polymers. So there's a very simple representation here. So monomers is represented by these blobs, and they're joined together by covalent bonds to make a polymer. Now, if we actually look at the actual chemicals, so this is a chemical called ethene, and you get multiple ethene molecules reacting to make this polymer, which is called polyethene. But we can actually call it polythene because it's easier to say. So if I had polychloroethene, so the poly, so we don't normally put the brackets in, this is just to illustrate the process. So the poly means it's a polymer, and then the chloroethene is the name as the monomer from which it was made. So let's have a bit of practice here. So I've already told you the answer to the first one. So ethene, so all we do is we write the word poly. So for each of these, we just start with poly. So remember, these are the names of the monomer. And it becomes, so all I do is I write the word poly, I'll write the prefix poly, and then I just write the name of the monomer. So ethene becomes polyethene. You can pause the video now and have a go at these yourself if you want. Propene becomes polypropene. Styrene becomes polystyrene, which you've probably heard of, it's used in packaging. And then chloropropene becomes polychloropropene. So you should be able to do it the other way around as well. So if you were given, so to reverse, if you were given polychloroethene, then all you do is you just remove the word poly, and it becomes, the name of the monomer would be chloroethene. Okay, so you need to be able to do it both ways. So if you're naming the polymer, you just add the prefix poly, and if you want to name the monomer, you just remove the prefix poly. So there's a good video on thermo softening and thermo setting polymers if you watch this video link here. Here's a diagrammatical representation of thermo softening and thermo setting. So you can see the differences in those diagrams. So in thermo softening, you've got these big long chains which aren't linked together. So even though that's shown as crossing over in the diagram, they're not linked. So I could easily, we could move, those chains can kind of slide over each other. So you've got tangled chains, but they're easy to separate because they're not linked together. So they're called thermo softening because when you heat them up, they soften a bit, and then you can change shape when they're heated. So if you want to change, if you've got a polymer, which is thermo softening, and you want to change its shape, you just heat it up and then you mold it into a different shape. And that's possible because there's no links between these chains. If you've got links between these chains, it makes it less flexible. So these chains can no longer move past each other, and therefore it's less flexible. So these chains are joined by covalent bonds. So these links are covalent bonds, and covalent bonds we know are very strong, and therefore you can't separate them easily, so it can't change shape. Right, there's a worksheet that you need to complete on the answers, so they're in the Teams folder. I'm going to talk you through the first few examples. So what we need to do is we need to be able to draw. So it gives you the structure of the monomer. So ethene structure of the monomer is this. And so all the monomers have got a carbon-carbon double bond. So if we need to draw out what the polymer looks like. So this is our monomer, which is ethene, and that's going to form the polymer polyethene. Although, as I said, in everyday life, we call this polythene because it's easier to say. So what happens is that carbon-carbon double bond, the double bond breaks, and then they react with each other. So you get multiple of these ethene molecules reacting with each other to form a big long chain. So if you're going to draw out the polymer structure from this, the first thing you do is you break the double bond. So I'm breaking the carbon-carbon double bond. So it then becomes that. So I've kept the single bond there, but I've broken the double bond. Then what you do is you draw the covalent bonds extending out to the left-hand side and the right-hand side. So what I'm doing here is I'm drawing one there and I'm drawing one there. We then draw a square brackets around the repeating unit. So draw a square bracket like that so that the bond there extends outwards, and then lastly I write M outside the bracket, and that's at the bottom, and that N just means a very big number. So it means we've got too many to count of these joined together. So that would be the structure of the polymer, the repeating unit. So that's the structure of the polymer, and the repeating unit is just this. So if I was to draw a big stretch of this, what you'd have is that's what my pen doesn't seem to be working. So we'll leave that extended out on there. So there's one of my repeating units, and then you just put another of the repeating units in. Okay, so that's two repeating units, and then I draw a third one in. And I could keep doing that forever, which is why we draw this, because otherwise you're just drawing it forever. And we don't know how big N is. Okay, so if I was to do chloroethene, so chloroethene is similar to ethene, it's just got one chlorine atom replacing one of the hydrogen atoms. So I'm going to do the same process here. So I break that double bond. I'll then draw side ones out there. Let's draw the rest of this monomer in. Sorry, I think I've lost my pen again. Okay, so I've broken the double bond, I've put that out there, and I now draw my square brackets, and then I've got N. Okay, so that's the structure of my polymer. Right, you should be able to have a go at this worksheet now. So hopefully you've done the worksheet and checked your answers. If there's anything you're not sure about, email me. So a few questions you need to think about before you finish. So what are the differences between thermosession and thermosoftening polymers? How are polymers similar and different to giant covalent molecules? And is the bonding in polymers weak or strong? So you could argue in some polymers it's going to be both.